Baraminology is the young Earth creation version of paleontology and taxonomy mixed together to find what a created kind really is. The initial rules actually first came out with Frank Lewis Marsh, who proposed that hybridization between species and crossbreeding as a test for determining which species belong to the same baramin. Creationists have applied these principles to many different groups. Today we've actually added domestication, so we can see the vastness of how diverse a species can actually get. However, Marsh's original test can't be applied to organisms known to only fossils, meaning we have to have something living to see how much diversity is within that species. And we can do that today because we're at the end of the line, right? So there should be more species now than there would be going back in time to the bottleneck. Then we have successive approximation. This works by splitting up bigger groups and adding them into smaller groups, until we get into statistical baraminology. This is the distance of character traits of each species which are identified. And this information is then entered into a statistical program that compares the similarity or dissimilarity among species. The findings can be plotted on a three-dimensional graph, which visually shows where species clump together and where they are widely separated. This is a new toolkit for baraminology which includes statistical methods that can help us identify the created kinds. They are baramitic distance, which measures the percentage of characters that two organisms have in common to determine how similar or dissimilar they are, and multidimensional scaling, which allows patterns of similarity and differences between organisms to be visualized in three-dimensional space. The computer takes this and renders them and then displaces everything that it has into groups. So this will help us in determining relation in the fossil record, which is really good. So what we do essentially is we look around at what we know is related in the animal family today and then take all of those differences and put them into a program. And this program will help us determine if anything that we find in the fossil record falls within this variation. And it works very good. But you want a lot of information. The goal of baraminology is to determine what a created kind species was. This is known as a holobaramin, and it is the end goal for all baraminologists. A good example we'll look at right now is that of penguins. So according to evolution, after you get past the family level, penguins converge with other bird species, specifically the puffins, auks, and murres. So, to determine if this was true, we want to look at every single species of penguin alive today and in the fossil record. We then can map out and count out all the differences in the variation that we see, every single little morphological difference, and then count them up. Let's say that there's 20 physical differences within the family. Now we go back to the supposed closest related bird species that evolution claims are related to them. We do the exact same thing with each of these species and then compare them to the penguin. Is there any overlap? Is there anything to connect them to one another, even via the common ancestor in the fossil record? Well, baraminology studies have shown us no, there is nothing, and not even close. What we see is a dividing line of discontinuity separating these different kinds. And we can see these clusters of species by color. Those that are related and those that are separated out nicely from those that are not related. This is what we should expect to see if young Earth creation is true, but not evolution. You see, evolution teaches that all things converge to a common ancestor that shares traits with all of the species that branch off from it. This is not what we find. However, with Todd Wood's Baraminology conclusions on human evolution, we actually do find this. I could be wrong, but it appears to me that it does, and we'll get into that. Now, remember, what matters most in a theory? It's predictions, right? Yes. So according to Baraminology, we would predict that there should be distinct groups containing Homo sapiens, Neanderthal, and Erectus. There also should be discontinuity between the Homo kind and species including Australopithecus and Paranthropus. Questionable taxa, of course, are Habilis, Sediba, and Naledi. But either group should fall into a category, and that's what we want to know. We do admit that there are features that physically morph over time, very similar to how this dog breed's facial structure has changed over time through breeding. However, this is accounted for in Baraminology. What we want to look for are anatomical differences, not morphology, such as changing of already existing structure over time. That brings us next into our next phase, looking at Todd Wood and his testing of predictions of human evolution using Baraminology. These are all publications by Todd Wood. Now, he has categorized what appears to me to be many different species of Homo. These charts show us that there are borders separating different kinds. This right here is one of the earliest studies. We will get into the most recent one next, but as you can see, if you look to the very bottom right in the green circle, that is Sediba. Notice what side it is placed on? On the human side. Now, this is what this video is all about. What is Sediba? Was it really human? Well, according to every other researcher, only Todd came to this conclusion. But that's fine, but we must understand why he did. The first thing we need to know is that he only used skull and teeth fragments in the program to obtain these results. I have no problem with this. But what we do know is that 1. Sediba is very few in total fossil fragments, and that there is only one skull to test on Earth. This made me research what other scientists had to say about this. So besides emailing Ella Bean, who said exactly what Donnie has been saying the entire time, that it's actually a mixed bred of human and primate bones, but that it is also a mixture of species that are both young and old. Now that to me is where the real problem comes in. Why? Because just look at the immature primate next to a mature primate today. So to find a young primate skull that looks more human should be expected. So if all we have that Todd is testing is a young primate skull, then clearly the program would place it on the human spectrum. But let's see if anyone else has actually noticed this. And they have. I found this interesting article on Sediba, and the author states that it is nearly identical to the similarity found in Homo rudolfensis, youth's skull. He states, the Homo rudolfensis skull KNM-ER 62000 was the face of a juvenile, and so was the recently discovered Sediba skull. These two fossils are the same age of dental development, so they are roughly at the same stage of life. So as you can see in this picture on the left, and ER 62000 face on the right, what do we see? Let's read what the author says right here below. It says, what do you think? Pretty different, right? Wrong. Below, I have superimposed the ER 62000 face onto Sediba, slightly recolored and transparent for contrast. And look at that, fits almost identically. And remember, the face of ER 62000 is Homo rudolfensis, an ape species. But the young look very human-like still. The author of the article concluded by saying, maybe my eye was drawn to the ER 62000 Sediba comparison not because of any evolutionary relationship, but because these fossils are similar in stages of growth and development. So it seems to me that Todd obtained results in favor of Sediba being human because the skull of young primates does look more human. So it's not really bad science Todd obtained his results from. It's the physical, limited evidence that he had to work with that places Sediba, Habilis, and Rudolfensis into the human category. We can read here where he states, from Humors in 1977, the earlier call for caution regarding KM-MER 1470 in 1990 and Hartwig in 2007 rejected the human status of Rudolfensis because newer reconstructions of the skull suggested more affinities with Australopithecus than with Homo. This is why young Earth creationist David Minton mentions that Todd Wood believes that post-Babel dispersal of humans was led by Homo habilis and Homo rudolfensis. Now this is odd, because this would make Noah and his immediate descendants all midgets, since all of these species were found to be around 3 to 4.5 feet tall at most. So according to Todd Wood's Baraminology conclusions, we have Noah as a midget and all of his children, up until all of a sudden Homo heidelbergensis comes along. Which, by the way, springs all the way up to average day height at 5'9", all the way up to 7 feet tall.
Homo heidelbergensis. The males were about 5'9", so not that much shorter than anybody, in our modern day and age, 126 pounds. Again, this is an individual that if you saw them out on the street, you would, unless you looked twice, you would never know they were not conventional Homo sapiens. The females were about 5'2" and 112 pounds. Lee Berger in South Africa at Wits University has said that he believes he's found some of the specimens in South Africa that are taller than 7 feet tall. They may have buried their dead, and that's unique from the animal world.
What I found interesting, though, is that Wood admits that many disagree with what these species actually are. And he states, given the consensus creationist view of fossil hominids discussed above, we may make 3 predictions. First, there should be a monobaramin containing Homo sapiens, Neanderthal, and Erectus. Second, there should be a discontinuity, or at least a lack of continuity, between Homo monobaramins and species of the genre Australopithecus and Paranthropus. Third, the questionable taxa of Habilis and Rudolfensis should group with either the Homo monobaramin, and therefore be human, or with Australopithecus. They should not occupy an intermediary position. By contrast, an evolutionary interpretation would predict continuity between Australopithecus and Homo. But yet, what do I see when I look at these charts? I see exactly what evolution would predict by looking at Wood's charts. I mean, where would you expect to find a missing link on these charts? Right between humans and primates, right? Well, that is exactly where Sediba and Habilis fall when looking at postcranial characteristics, which, I might add, is the most important factor when placing something into a related category, even admitted by Todd Wood himself. So, when trying to figure out taxonomic-related placement in all things classified hominidia, or anything for that matter, we look for similar characters. So when we look at postcranial characters, and when we look at hand characters, we see a lot of chaos in the charts. Kinda looks like a smorgasbord. But let's zoom in. Look real close. This chart gets even more confusing. Remember, each related kind is a black box that is supposed to show in a grouping of a kind of like this. But instead, it looks to me like these are each separately designed hands, doesn't it? Shouldn't the hands of related human species group together with others such as Neanderthal and modern-day humans? Yet, if you look at the chart, it looks like either an independent origin or a transitional evolutionary line to me. I mean, look. It's a perfect line of transitions, going from Ramidus and chimpanzee, transitioning all the way up to Sediba, and then ending on us, modern-day people of today. That is exactly what evolutionists would look at and say, this is what we expect to see. I mean, isn't it? It's only when we look at craniodental characters that we can now place Habilis and Sediba into the human category of a monobaramin. I mean, look, we have Habilis and Sediba outside of the realm of human relation, using the most important characters from postcranial data. And in another study using the same thing, it's Habilis that moves into the human baramin, but Sediba is still outside of it. It ends up being the hands and the craniodental that move it into the human family. So the question is, if the species is a mixed bed with Homo bones and primate, wouldn't that give inaccurate results like this? Or what if it is the youth of a primate species that looks more human? Would that also give results that are not accurate? And if these results are true, well, we get some results that place some species close to the line of discontinuity. The evolutionists will again just point to this and say it's the perfect example of where we should find a transitional, wouldn't they? Since that is all the evolutionist is really looking for, to call something a transitional species, regardless of how minimal or how many differences there even are. But let's look at the most recent study. What does this chart look like to you? Well, to me it kind of looks like an evolutionary chart of slow transitional species. Starting at the bottom, we move from Africanus up to Pan, which is the chimpanzee, then transitional features all the way to Sediba and ending in Homo sapiens, Erectus and Heidelbergensis, which for some reason are even farther away than humans. I don't get that, this is a little confusing. We also see on the right, looking at this side of the graph, a green and red square kind of near the middle. This must be those features that have the least distance from one another. Well, wouldn't an evolutionist just try to say, well, that's exactly what we want to see. This is the transitional species. It's really close to the other one. Well, my question is then why are we finding anything with these close similarities if there's no such thing as a transitional? To me, what makes the most logical sense is that we are looking at just a mixed bone bed of Homo and primate species. And clearly, even the experts still don't know what they're looking at, because they admit this. Maybe these charts that I'm looking at are just reduced in size, and perhaps if they were blown up larger, that distance of gap would actually be really large? Is that what's going on here? Maybe I'm just overthinking this whole thing. I've read through the study, and I can see how things are grouped together, but there's also things that move very close to the other side. But let's look at this next chart. Again, we see groups diverging, but getting closer to one another. Couldn't the evolutionists just say, take the two closest, and anything of these colors will just say, yep, those are transitionals? What could we say to refute this? We also see on the right of this chart, the green box is fairly close to the red box, which is another character distance. The red is supposed to be the human group. So wouldn't this classify that close green box as a species that the evolutionist will just say is a transition? I guess for me the biggest problem that we have is that the results have placed these specimens together without having enough of the postcranial data, which they admit is the most important features when it comes to placement. And this is our entire argument. All of these bones are contested. They are fragmentary, subjective, low quality, low confidence. Even looking into the past, it's not just evolutionists who disagree on what these things are. As you can see, not even young Earth creationists can agree. And that's the whole point. This field is a mess, and I like that Todd Wood is trying to bring some clarity and answer these tough questions. But this doesn't mean we should just jump the gun and start placing these things into groups and acting like the evolutionists until we have all the data. But going back to the first study, we can see that when they looked at only the craniodental data alone, in which they moved both of these from where they were on the line of discontinuity and placed them neatly in with what they believe to be all different human species. However, let's look closely at the chart they have. Again, I ask, where would you expect a missing link common ancestor to fall on this chart? Right in the middle, correct? Exactly where the line of discontinuity should run? Well, more bad news it seems. Look, another species right in the middle where evolutionists can easily claim this is just another transitional. Am I missing something here? Are these results really not a mix of human and ape features? Isn't that what the definition of an intermediary is? You see, this is the problem with coming to conclusions before all the evidence is in. We literally only have minimal physical evidence of very few specimens that are mostly broken into pieces, disarticulated bones mixed with other creatures, all while having adults and minors mixed together. To me, this type of science would be like me as a fighter trying to figure out who my opponent is a week before the fight. So I send somebody over to investigate his training camp, but no one's there. So instead, they look throughout his workout bag and find some boxing gloves, and we all assume that he's a boxer. And then on fight day, we actually read that he's a wrestler who's only been training in boxing for a few months to help bring up his greatest weakness. This is a lot like how paleontology has been. Its record in the past has been nothing but failure after failure and presumptions, which have turned out to all be wrong. And here we have another example of them jumping the gun when hardly any of the information is actually in. Do you know why evolutionists do this? Because it is their biggest window for storytelling, and it's been like that since the early days of fossil discoveries. The unfortunate part is people want answers by us young Earth creationists on what these things are. So I have no problem with Todd Wood categorizing and placing these things somewhere, but he really needs to admit that this information is very weak and not something you should proclaim as evidence for young Earth creation yet. At least he does admit this. The lack of postcranial information in the study is especially important, since one of Hartwig's 1998 objections to including that Habilis in the human basic type, Monobaramin, is the ape-like nature of Habilis skeleton OH62. It is possible that inclusion of postcranial characters in future baraminological analysis might support the separation of Habilis and Sediba from the human holobaramin. What we do see a lot of, though, are the criticisms of his work. even looking at just the skull. For example, David Minton shows how the skull has no nose bone, and even human children have this. Instead, it's like a primate, and the teeth are already starting to protrude, and you can see the mouth itself is starting to extend, just like primates do. He goes on to say that Wood obviously had no access to the Australopithecus Sediba fossil, which hominid fossils in general are rarely made available to discoveries. So unfortunately, Wood uncritically accepts the evolutionary claims of certain anatomical similarities of Australopithecus Sediba to humans as hard data rather than opinion. He does a statistical analysis of these opinions as though they were objective fact. But how similar is Sediba to man? Well, paleontologist Tim White said that characteristics shared by Sediba and Homo are few and could be due to normal variations among Australopithecines. We also have paleobiologist Professor Ella Bean replying to us directly via email, who said Sediba is nothing but pure fiction. So it seems to me we found an extinct primate species, mostly like Rudolfensis, that was 4 feet tall that had mixed in with it Homo bones. This smorgasbord of fossils were then pieced together like a puzzle, and to the average human eye it looks like the perfect intermediary. We read here from other evolutionists like Lyell and Thomas, who both said, "I don't agree that it's human, and neither do most evolutionists." So isn't that ironic? Most evolutionists, not some, not part of them, not 50-50, most. So when people like Erica or Paleologos say that this is a rescue device, well, I don't think they've actually read any of this information. So in conclusion, based on the discussion above, it would appear that the statistical Baraminology results placing Homo habilis and Rudolfensis and Sediba within the human holobaramin is a false positive result. This is most clearly demonstrated from Sediba and therefore raises questions about Habilis and Rudolfensis. And I would completely agree with this because of the other study that I found above, which showed when you place Sediba next to Rudolfensis and over the skull that they have, it's nearly identical. So what are we seeing? We're seeing a miscategorization. That's all it is. I think we as young Earth creationists want to know what layers are after the flood. And we use fossils found in those layers to help us determine if a species is related coming from Noah's Ark, or are they pre-flood. What I have noticed is that all animal fossils that are found before human fossils are found, looking at post-flood layers. This makes logical sense to me, since animals migrated first and mankind did not until after the Tower of Babel. So as you can see from this chart, the flood boundary is the KT boundary for me, and a lot of young Earth creationists. It seems to me that right after migration took place, that primates made their way into Africa by the time of the Eocene layers. These are not exactly different ages as the names seem to imply. These different layers exist only because of the radiometric dates scientists obtained from them. Since we now know that these radioactive elements form already dating old, the ages they present to us mean nothing. And since the distribution of all radioactive elements comes down to weight, then logically it only makes sense that over time, and because of the flood, heavier radioactive elements would sink deeper, and this is the type of distribution that we find. Then it should be no surprise to a young Earth creationist or an evolutionist that the deeper rocks would have older dates. So now, notice that we have primates in the earlier layers formed right after the flood, before mankind starts to inhabit Africa. What does this tell us? Well, since I believe this is what we should expect to find, based on the biblical model of ancestry, from these primate species, we would expect more speciation to come later, right? More diversity of the primate kind. Why? Because they can speciate. Humans cannot. What do we see? Exactly that. We have evidence of the first ape species arriving in Africa and leaving behind fossils in the Pliocene layer, as they have been discovered in North and Eastern Africa, which is where they would first arrive if Noah's flood was true and migration came from the northeast. Then we find new primate species spreading across the continent. In closing, all I have to say is that these rare fossil finds seem to me to match juvenile primates misconstrued as having features of man. The bones are often mixed with other fossils, making identification very speculative. with confusion even among the experts. Too few overall fossils exist to come to any real conclusive conclusion. But what seems to me is that there are indications we are looking at adolescent extinct species of primates that share identical features with one another, that have been used by evolutionists and now, unfortunately, young Earth creationists as evidence for whatever they want to share features with that make them a transitional-looking missing link. So basically, Todd Wood put a nail in our own coffin by trying to place these as either directly human or directly primate, when we're probably looking at a mixed bone bed and adolescent primates. Is finding a bipedal primate species really a problem for young Earth creationists? I would say no, not really at all, because is the litmus test for what makes something human really walking? If it was, then cripples who can't walk would not be classified as human. So I guess the real question would be, what would an intermediary ape-to-man species look like? Well, I think that we should look for something that are basically primates, but with a few features that are only found in humans, such as the baculum, or the nose bone, or a hyoid bone for speech. I would also be content with finding primate bones that are more like human bones today. Or how about when we're looking at facial structures? Then we can look at what the teeth tell us. For if these are really adolescents, then let's look at their premolars. Do we see what ape species have? Are we looking at an ape species but that don't have any of the triangular shaped premolars? Well, that would be an example of a transition. But overall, a human being, or a person, is distinguished from the animal. This is the definition of a human. There is a line. So I like the work that Todd Wood is doing. Don't get me wrong. I just think that in the fossil record, regarding the majority of these ancient extinct species, there is far too little evidence to go on to give any real definitive answers. Until we find more, these taxons should remain unclassified for us young Earth creationists. We don't want to be like the evolutionists where they've predicted everything wrong because they were so early to jump to conclusions with such little evidence. So why can't humans have as much variation within us as, say, other primates or animals? Well, that's easy because we cannot speciate. Animals can. Let's use evolution to disprove this idea of human speciation. According to evolution, over 30,000 years, Australian Aborigines have been isolated on that island. This is 1,200 generations of reproductive isolation. Yet, when people came on the scene much later, breeding with them was not a problem at all. Yet in the animal kingdom, even as little as just 2 generations, we can find species that can no longer breed with the parent species. So clearly 1,200 generations is more than enough time to cause a new species between human beings. This is just one of many examples of human isolation and how no speciation event has ever been witnessed or occurred. So if humans are not able to speciate, this really helps us narrow down the physical limitations that are within us as a single holobaramin, since most variation in the animal kingdom comes from their ability to speciate. We as young Earth creationists know that the confusion for Todd Wood's view on Neanderthal comes down to mtDNA differences, and how Neanderthal look a little bit different than what we have found in people alive today. But this is accounted for, and I'll explain it from a portion of my last video where we discussed Neanderthal.
Homo sapiens neanderthalensis. Until fairly recently, Neanderthals were considered to be a separate species from humanity. They are not. They are us, but they are us in a different form. By and large, we are the same species. Long, long ago, people thought we came from Neanderthals. And we do indeed have Neanderthal DNA in our systems. But by and large, what we're finding out in the last 10 years is that they are us, but modified for a cold climate.
And yes, cavemen are mentioned in scripture. These people were never missing links in the line of human evolution. The Bible perfectly details who they were. Unfortunately for them, they became isolated with a shrinking population and died from incest. And yes, we have evidence for this.
They lived together in small groups and reproduced amongst themselves, and that could cause genetic problems. A healthy gene pool needs constant imports and exports of material.
Il faut imaginer It appears that they lived in small groups with perhaps 20 or 30 people. A large clan might have 2 or 3 families. These small groups moved over relatively large areas.
Well, think about it. How could a small population confined to inbreeding last? Well, that question has been asked, and a new study has found that there is no possible way that Neanderthals could have existed for even over 10,000 years. So much for 400,000 years, huh? Everything they thought is literally crumbling and falling in between their fingers. And they still can't see the obvious.
The Neanderthal Y chromosome, which for a long time we didn't even have one. It was the weirdest thing that every time they sequenced a Neanderthal skeleton, it was a female. But then they finally found a male, and we had this partially sequenced Y chromosome. It was really degraded, it was really bad quality. We had that for a long time, but just a year or two ago, someone went and did a high quality construction of a Neanderthal Y chromosome, and it was very similar to that of modern man. And that was a surprise, because now the Y chromosome atom between man and Neanderthal is much more recent than they used to say. So their Y chromosome is very human.
So yes, Neanderthals are best explained in our model, and everything about them tells us they were just normal people who lived alongside of other humans, and all others today are still related to them in some way or another, because their parents were our grandparents. So of course we're all going to share some genetic relation with them. And yes, even Africans, whom evolutionists denied, by the way, that would ever be the case. So you see, at first they said they were a totally different species. But then they had to admit, well, they can breed with us. So that idea was removed from them being a different species by definition. Then they tried to say that, well, they're a subspecies, just a different offshoot branch of humans. Then that was falsified when they found Denisovan and modern day people share a lot of genetic similarity with them. Then they said, well, they're not a different species nor a subspecies, but they're just a single dead-end branch of only the European ancestry through evolution. But then they found that even Africans have their DNA in them as well, so that falsified that idea too. Basically, everything that they once said about them has turned out to be 100% wrong. These were just sons and daughters of one of Noah's grandchildren who were vile and detestable people and were outcast and sent away. And they died from genetic disorders from living in small numbers and inbreeding over the 1,000 years. This also explains their lack of chin, which even modern-day Australian Aborigines share because of this inbreeding problem that they have as well. So the last question would be, why don't we share more genetic similarity with these ancient Neanderthal if they just lived a few thousand years ago? Wouldn't it take tens of thousands of years for DNA similarity to be weeded out? Actually, no. And published in Genetics, a team conducted simulations to model what would happen if Neanderthal did indeed occur mutations at a quicker rate than modern humans. What would happen to the offspring shared between humans and Neanderthal? Well, the study revealed that rather than genetic similarity slowly declining over time, Neanderthal DNA in modern human genomes would have been rapidly decreased during the first 10 up to 20 generations. So a time period of less than 600 years maximum. Then it would remain unchanged throughout all future generations. And this is exactly what we see. Neanderthals, being a product of evolution, is falsified. But now let's listen to what evolutionists have to say about Neanderthal and when they flip-flopped on what they once said was a fact.
The science constantly changes how we envisage Neanderthals.